Hello and welcome to my lecture series on theory of probability. Now you must be wondering that why I have chosen this topic of theory of probability in my lecture series. Now this is basically due to three reasons. The first reason is that I find that in my years of teaching, this theory of probability is a very important subject for any science or engineering student. Simply because this subject has a lot of application later on in almost any branch of science and engineering. Secondly, nowadays I have found that theory of probability is used as a tool to test the aptitude of a particular student. If you consider some examinations like GATE or CAT, you see that in everywhere or any other competitive examinations or any other government examinations, you will find that in the aptitude section there is a lot of problems on theory of probability. And the third reason is that I have found in my years of teaching that in this particular subject I have found that most of the student faces a lot of problem. So these three reasons have decided me to start my lecture series with this particular topic on theory of probability. Now this theory of probability is a very interesting subject. Okay, you don't need much of mathematics to understand this topic of theory of probability. What you need is actually that your logical mind actually, so that you can apply your mind to solve those types of problems which you might face in your daily life, right. Now I will be going into this topic of theory of probability, but before that what I think is that there are some prerequisites to learn this particular course of theory of probability. Now what are the two very important prerequisites I find are very important, otherwise it will become almost impossible to understand the concept of probability, and they are, one of them is permutation and combination and the other one is called set theory. So I have decided to start my discussion on this lecture series on probability with the concept of permutation and combinations. Now permutation combination is a very conceptual subject, and because this subject is basically taught in +2 level. Now the whole concept of permutation combination is based on counting. Now how well you can count, or rather I will say that what are the rules you know to find out the different types of counting is what is all about permutation and combination. So to go into the deeper concepts of permutation and combination, the first thing that you should know is the fundamental principle of counting. Because this fundamental principle of counting, if that is not clear, then it will be very impossible or almost difficult for a particular student to understand the concepts of permutation and combination. So I start my lecture with the concept of fundamental principle of counting. Now I just start with a very simple example. Let's say I am asking you, let's say I have a rectangular array of numbers, right. Let's say I have a rectangular array of numbers. Let's say we have 6 columns, right. Let's say we have 6 columns and we have 5 rows. Okay. So I write the elements one by one, elements or any numbers or whatever it is, or so we write the elements right one by one. So there are 5 rows I will consider. Okay. So this is 4th row and this is the 5th row. So how many columns we have? We have actually 6 columns. And how many rows we have? We have 5 rows. So we have basically 6 columns. We have 6 columns, right. Okay. And we have how many rows? We have 5 rows. Now a simple question I ask. Now this is a rectangular array basically, because this is an arrangement of numbers in rows and columns. Now I ask you a very simple question that tell me how many numbers are there in this rectangular array. Then what should you do? Will you be counting one by one like this, 1, 2, 3, 4, 5 like this, right, from this to this, or will you apply some technique to find out the answer in the quickest possible way? I think the most easiest way of finding out the answer to this, that is how many numbers are there in this rectangular array, will be to find out how many columns this array has. It has 6 columns and it has 5 rows, right. So what I will do actually, I will just multiply 6 columns with 5 rows, and 6 into 5 will give me 30. So obviously I have 30 numbers in this rectangular array. So what I have done actually is that I have just implemented a rule, that is I have defined a rule by which I can count these numbers in this rectangular array. Now this entire permutation and combination is based on counting. So the emphasis should be given on the counting principle. So as you can see, there are basically two principles of counting. One is called the multiplication principle, the other one is called the addition principle. Okay. Now I will come to this, see the best way of explaining this principle is with some examples. Let us take a very classical example to define this concept of this multiplication and the addition principle, right. Now if you look at the first example that I have taken, that in that example it has been asked that in how many ways can I wear an outfit if I have 2 shirts, 3 pairs of trousers and 2 pairs of shoes. So that is the question asked. So in how many ways can I wear an outfit, right. Now how do I answer this question? Now I will answer this question exactly using the fundamental principle of counting, okay, which I am going to explain with this particular problem. See how we answer this question. Now see how many shirts we have? We have 2 shirts, right. So we start here, let us say I am here, right. So I have 2 options to wear a shirt, okay, either, see I cannot wear 2 shirts simultaneously. So either I will wear shirt 1 or I will wear shirt 2. So I can either wear shirt 1, which I am calling as say S1, and or I can wear shirt 2, which I am calling it as S2. So I am wearing either shirt 1 or shirt 2, right. Now fine, so I have two options to wear a shirt, fine. Now for each one of those options of wearing shirt 1 or shirt 2, I have 3 options of wearing a trouser, because I have 3 pairs of trousers. So if I wear shirt S1, then I have 3 more options of wearing a trouser with this shirt S1. Let us say the trousers are named as T1, T2 and T3, okay. So T1, T2, T3 are the 3 pairs of trousers I might wear if I wear the shirt S1, but I might also wear the shirt S2 also. So if I wear the shirt S2, okay, then also I have again 3 more options of wearing 3 different trousers. So again I can wear trouser T1, I can wear trouser T2 or I can wear trouser T3, right. So I have 3 options of wearing a trouser if I wear shirt S1, and I have 3 options again if I wear shirt S2. But that's not all over, because I have 2 pairs of shoes, because an outfit means shirt, trousers as well as the shoes as per the data given in the problem. So I have 2 pairs of shoes to wear. So since I have 2 pairs of shoes to wear, so basically now you see if you go back to this diagram here, okay, you have now if you wear shirt S1 and let us say you are wearing trouser T1, you are wearing shirt S1 and you are wearing the trouser T1. So obviously when you wear the trouser T1 with the shirt S1, then for that particular dress you have 2 more options of wearing 2 pairs of shoes. So that means you have an option of wearing either a shoe, let us say we call it SH1 for the first pair of shoe, or you might wear SH2, which is the second pair of shoe. So you have 2 more options of wearing a shoe, okay, if you wear shirt S1 with the trouser T1. Now let us say if you want to wear the trouser T2 with the shirt S1, which is also another option. Now in that case also again you have 2 more options of wearing a shoe 1 as well as a shoe 2, SH2, right. By the same logic, if you wear the shirt S1 and then wear the trouser T3, you have again 2 more options of wearing a pair of shoe, that is either you can wear the shoe 1 or you might wear the shoe 2, that is SH1 or SH2, right. Same thing happens here. Now if you wear the shirt S2, okay, if you wear the shirt S2 and wear the trouser T1, then you have 2 more options of either wearing shoe S1 or shoe S2, right. Same thing happens here. If you are wearing the shirt H2 and the trouser T2, then you might wear either shoe 1 with that combination, or you might wear shoe SS2 with that. So again you have two more options if you wear S2 with T2. Now the last option will be if you wear shirt S2 with the trouser T3, okay, again you have two more options with that corresponding dress. So therefore you have two more ways of wearing the shoes, that is SH1 and SH2. So what we find is that that is all. So because we have three categories, there is two shirts, three pairs of trousers and two pairs of shoes. So we can end this node here. So basically, so once we are ending this node, if you look carefully, okay, it is forming a tree. It is actually forming a tree. This is called the tree diagram, okay, because it is exactly a tree that we have formed. This is the root node, and this is actually we use in the concept of graph theory. So this tree diagram actually helps us to find out that how many ways can I wear an outfit. Now how do I find that? That's the main question, that how do I find out that how many outfit can I wear if I this combinations of shirts, pairs of trousers as well as the shoes. Now that can be easily obtained by counting the number of leaf nodes of this particular tree. Now what are the leaf nodes? The leaf nodes are these nodes. So how many leaf nodes we have? The number of leaf nodes of this tree diagram corresponding to this problem is actually the number of ways you can wear an outfit where you have two shirts, three pairs of trousers and two pairs of shoes. So we just count the leaf nodes and get the answer of this first problem. So how we count it? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we get 12 cases. So we get 12 nodes here. So therefore 12 ways are there by which you can wear an outfit where you have two shirts, three pairs of trousers and two pairs of shoes. So that is the way to find out the answer in a particular problem, but this was possible because the data were very less given to me. In case the data is quite huge, let's say you have more options of shoes, you have more options of trousers or more options of shirts, then the tree diagram will become more and more complicated. So in that case it is not advisable to use the tree diagram to find the answer of these types of question. So there must be a way of finding out a solution to this. Now what is the solution? The solution is how we get it. Now how many shirts we had? We had basically two shirts. We had two shirts. How many pairs of trousers we have? We had three pairs of trousers. Three pairs of trousers, right? And how many pairs of shoes we had? We had basically two pairs of shoes, right? Two pairs of shoes. So we had two shirts, three pairs of trousers, two pairs of shoes. Now what is exactly happening? Why is turning out to be a tree diagram? I'm telling you once again, and how we come to this principle. Now you see, initially you are here, you have two options of wearing a shirt. So you have two options of wearing a shirt. So we write two here. So there are two ways that you can wear a shirt. Now for each one of those two ways of wearing a shirt, how many ways that you can wear a trouser? You can wear a trouser in three ways. So it is 3. And for each one of those 3 ways of wearing a trouser, you have how many ways of wearing a shoe, pair of shoe? 2 ways. So it is 2. So what happens is that for each and every way of wearing a shirt, there is 2 ways of wearing a shirt, you have 3 ways of wearing a trouser. Therefore, what is the total number of ways that you can wear a shirt and a trouser? So it will be 2 into 3, that is 6 ways. 2 into 3, that is 6 ways you can wear a shirt and a trouser, provided you have 2 shirts and 3 pairs of trousers. Now once it is done, now for each one of those 6 ways, see, these are the 6 ways, 1, 2, 3, 4, 5, 6. Each one of those 6 ways of wearing a shirt and a trouser, you have 2 more ways of wearing a pair of shoe. So therefore, the total number of ways that you can wear an outfit will be 2 into 3 into 2. and that is coming out to be 12, which I have just now calculated by counting the total number of leaf node in this tree diagram, right. So the idea is that I have actually implemented the fundamental principle of counting, which is the multiplication rule. So if I go back to my previous slide, you will see that in the multiplication principle which I have wrote, that suppose an event E can occur in m different ways, and associated with each way of occurring of E, another event F can occur in n different ways, then the total number of occurrence of the two events, that is both the events simultaneously, will be m into n, and that is exactly what is happening here. See, what I told is that suppose I have m ways, of doing a particular thing. I have m ways of doing a particular thing, and for each one of those m ways of doing a particular thing, let us say I have n ways of doing another thing. So for each one of those m ways of doing a particular thing, I have n ways of doing another thing. Therefore, the total number of ways by which I can do both the things will be m into n, and that is what is exactly the multiplication principle is all about. So that is the principle we have adopted in finding the solution to the first example that I have taken, which is coming out to be 12. So 12 outfits you can wear if you have 2 pairs of shirts, 3 pairs of trousers, and 2 pairs of shoes. Okay, so it is coming in by the formula 2 into 3 into 2 by the fundamental principle of counting using the multiplication principle, and that is coming out to be 12, because you need to wear a shirt as well as you need to wear a trouser as well as you need to wear a shoe. So it is sometimes also known by the name AND rule. AND means that this thing is occurring and as well as this thing is occurring. So both the things are occurring simultaneously. Like here in this case also, you see that you need to wear 2 shirts, and you need to wear a trouser, and you need to wear a shoe to wear an outfit. So therefore all the 3 things will occur simultaneously, and therefore that's why the multiplication principle has been adopted, and therefore that will give me the answer 12. Okay, so the multiplication principle is also known by the AND rule. The famous AND rule in the fundamental principle of counting is also known by the name multiplication principle, right. Now there is another principle which you see I have written, it's called addition principle. Now what is this addition principle? Now again I will be coming back to the theory but I will be explaining this addition principle once again with a problem, a very classical problem I have taken. Okay, if we just go through the problem, you understand. The problem says that there are 3 different routes, right. I just read the problem first. There are 3 different routes between city A and B, 2 different routes from city B to C, okay, 5 different routes from city A to D, and 4 different routes from city D to C. Now the question asked is that in how many ways can I move from city A to city C? That is the question asked. Now again I can solve this question by drawing a diagram. That will be a much better way of explaining it, and I will tell you that why I am going to use the addition principle here, because addition principle has to be implemented here, otherwise the solution of this problem can't be done. Okay, so let us go into the solution of this particular problem. So there are 4 cities, you see there are actually basically 4 cities, city A, B, C, D. Now what is the first statement? That there are 3 different routes between city A and B. So let us say I draw this as city A, let us say this is the city A, right, and let us say this is your city B, this is your city B, okay. Now how many routes are between A and B? There are 3 different routes. So we write these routes as this 1, 2, 3. So there are 3 different routes by which one can move from A to B, okay, fine. Then from B to C there are 2 different routes. So let us say somewhere C is somewhere here, C is somewhere here. So from B to C there are how many routes? There are 2 routes. There are 2 routes by which you can move from B to C, okay, clear, fine. Now 5 different routes exist from A to D. So let us say a D is somewhere here, let us say D is somewhere here. So 5 roots. So 1, 2, 3, 4 and 5. So there are 5 different routes from city A to city D, right, and we have 4 different routes from D to C. So 4 routes from D to C. So 1, 2, 3 and 4. So these are the 4 routes by which one moves from city D to city C, fine. So I have basically drawn the diagram of which shows that the different routes existing between the 4 cities, they are connected, right. We are basically getting a connected graph, okay, fine. Now question is, in how many ways can I move from city A to city C? See, there is no direct route between A to C. If you want to go to A to C, you have to either travel to B and then move to C, or you have to travel to D and then move to C. You cannot go from A to C directly. Can we go? We can't go, right. So yeah, if somebody is standing in city A and wants to move to city C, so one has to make a choice that whether he wants to go to B or D. So he has 2 options of going to C by either visiting B or D, right. So there are 2 ways that he can do it, right. There are 2 ways he can do it. Either one way he can do it, the one way that he can do is that he can move from city A to city B and then move from B to C, right, or he may move from A to D and then move from D to C. So there are 2 possibilities. How many possibilities are there? There are 2 possibilities. There are 2 possibilities, right. The 2 possibilities are is that that is, you move from A to, we move from A to B, and then from B to C, that's all, you reach A to C. Or there is an or between. Why is the or between? Because you cannot go to B and D simultaneously. Either you go to B or you go to D, because and also the fact that you cannot go to A to C directly. As you see the diagram, there is no direct route between A to C, you have to go via B and D. So the or will come because of the second option. The second option is either you go to A to D first, right, and then move from D to C. So you have 2 possibilities, either you move from A to B and then move from B to C, or you move from A to D and then move from D to C. So these are the 2 possibilities we have. Now how we find the answer to this question, because my question says that you find out how many ways you can move from city A to city C, right. Now let us calculate the first case, that is when we are trying to move from A to B then from B to C. Now in how many ways can I move from A to B? I can move from A to B in 3 ways. I can move from A to B in 3 ways, okay, I can do that. Now in how many ways can I move from B to C? 2 ways, because there are 2 different routes. So 2 ways I can move from B to C. Therefore in how many ways can I move from A to C via B? So it will be moving from A to B and moving from B to C, because you have to move from B to C, because objective is to reach C. So this becomes like this, that is A to B, moving A to B and then from B to C, right, A to B, and there is an ampersand and, that means the multiplication principle to be adopted here first. So A to B, the number of choices, the number of ways is 3. Just now I told you 3 ways by which can move from A to B, and means into. Just now I told you the multiplication principle in the fundamental principle of counting, and you can move from B to C in 2 ways. So it's 3 into 2, 6 ways you can do that, because for every 3 ways you can move from A to B, there are 2 other ways by which you can move from B to C. Therefore the total number of ways you can move from A to C will be 3 into 2, which is 6 ways. So from A to B and B to C you can move in how many ways? You can move in 6 ways, which we have found out. Now having found that, in a very same way and same logic, we can find out this case also, the other case. That is, the other case is, that is moving from A to D and then moving from D to C, because you can move to A to C the other way also. The other way is via the city D. So first you move from A to D and then you move from D to C. That's the other option, the only other option you have. So A to D, how many ways you can do it? 5 ways you can do it, because there are 5 different rules between A and D. So 5 ways you can reach from A to D. So from A to D I can reach in 5 ways. Now once I do it, and I need to move from D to C, because and means both are occurring simultaneously, because I will not get stuck at D. Objective is to reach C. So that means I have to move from D to C. So that I have to consider. That's why it's and, it's not OR rule. So therefore and means into, right? Okay. Now from D to C there are 4 different ways of doing it. Fine. So there are 4 ways of doing it, because there are 4 distinct routes between D to C. So therefore how many ways I can reach from A to C via D? The 20 ways I can do it. So 20 ways I can move from A to C via the city D. Okay. So 20 ways I can do it from A to C via D. 6 ways I can do it from A to C via B. So this case will be 20 ways, right? So we have found out the individual ways of moving from A to C via B or via B and via D. Once we have found that, then we will be able to answer this question now. Now since I had told you in the beginning that either this case exists, either you have to follow this route or you have to follow this route, because you cannot follow both the routes simultaneously, because one can move either to B or D, cannot go to B and D simultaneously. That's the absurd thing. So the OR rule to be applied between these 2 cases. OR means actually addition rule. Okay, just like AND means the multiplication rule, the word OR actually stands for the addition rule in the fundamental principle of counting. Now in the fundamental principle of counting it says that if you can do a thing in m number of ways, and if you can do another thing in n number of ways, and let's say both the things are not occurring simultaneously, either one of them will occur, either or. It is either this event or that event is going to occur. In that situation the addition rule is to be implemented. So therefore this is exactly the same situation that has arisen here. That means I need to find out in how many ways I can move from A to C, because I have found out how many ways I can move from A to C via B. I have also found out the number of ways of moving from A to C via D. So therefore the number of ways I can move from A to C will be either this or this. That means my answer will be 6 ways plus 20 ways, that is 26 ways I can move from A to C. Okay. So the total number of ways, one moves from A to C is, it will be 6 plus 20, and that will be 26 ways. So 26 ways are there by which you can or one can go from city A to city C. And you see that in this particular problem we have not only implemented the addition rule, we have also used the multiplication rule of counting. So these rules are very, very important actually, because unless one is clear about these rules, it will be practically very, very impossible for one to understand the concept of permutation and combination. So that's all for today's class. In the next class we will be going into the concept of permutation. Thank you.